Hi everyone, welcome to the channel. In this video, I would be going to discuss about similar triangle and trapezium, the relationship between similar triangle and trapezium, give the details on problem solution of similar triangle and trapezium covered in this video. Get started. First of all, trapezium. Trapezium is a quadrilateral. One pair of opposite sides are parallel. Quadrilateral have two sides of opposite sides, ABDC opposite side, BCAD opposite side. If one pair of opposite sides are parallel in quadrilateral is trapezium. Both pair of opposite sides are parallel is parallelogram. All parallelogram is trapezium, but all trapezium is not parallelogram. One pair of opposite side is parallel, other pair is non-parallel side in trapezium. AD parallel to BC, AD and BC is parallel side, AB and DC is non-parallel sides. Problems here related to trapezium and a similar triangle. ABCD is a trapezium with AB parallel to DC, E and F are points on non-parallel sides. AD and BC respectively such that EF is parallel to AB, show that AE upon ED is equal to BF upon FC. Here ABCD is a trapezium, AB parallel to DC, EF parallel to AB. Given. Solution. Given AB parallel to DC, EF parallel to AB. Required to prove AE upon ED is equal to BF upon FC. ABCD is a trapezium, EF parallel to AB. Join AC. Meet EF at G. AB parallel to DC is given, EF parallel to AB given, and GF parallel to AB. Here, consider the triangle CAB. Triangle CAB, GF parallel to AB. So, GF parallel to AB, here applicable in basic proportionality theorem. CG upon AG is equal to CF upon BF, basic proportionality theorem. GF parallel to AB, basic proportionality theorem, CG upon AG is equal to FC upon BF. Another triangle ADC, EF parallel to DC, then EG parallel to DC. Here also basic proportionality theorem, AE upon ED is equal to AG upon CG, taking reciprocal on both sides. ED upon AE, CG upon AG. Equation 3, compare equation 1 and 3. One side is CG upon AG, first equation. Third equation, CG upon AG. Then other two side, FC upon BF is equal to ED upon AE. Taking reciprocal on both sides, AE upon ED is equal to BF upon FC. So, here the solution is over, hence proved. Another problem, ABCD is a trapezium in which AB parallel DC and its diagonal intersect each other at the point O. Show that AO upon BO, CO upon DO. Solution, ABCD is a trapezium, BD and AC is a diagonal, intersect at O. Try a parallel line through O. EF parallel to DC by construction. Given AB parallel to DC given, EF parallel to DC by construction. So here take any two triangles. One side is common for both triangles. Here can take any two triangle. One side is common for both triangles. So here two triangles. Take triangle CAB and triangle BDC. Can take triangle also ADC and DAB also can take any two triangles. One side is common. Triangle BDC, OF parallel to DC. If OF parallel to BC, then DC basic proportionality theorem, OB upon DO is equal to BF upon CF. Equation 1. Triangle CAB, OF parallel to AB, Then CO upon AO is equal to CF upon BF. Taking reciprocal on both sides in this equation, AO upon CO, BF upon CF. Equation 2. Compare equation 1 and 2. One side is BF upon CF. BF upon CF. Right hand side is equal, then left hand side also equal. BO upon DO is equal to AO upon CO. Taking reciprocal on both sides. Reciprocal not a cross multiplication. AO upon DO and CO upon DO. So here is the solution. Here over. The diagonals of quadrilateral ABCD intersect each other at the point O such that AO upon BO is equal to CO upon DO. Show that ABCD is a trapezium. Trapezium ABCD. AB parallel to DC. Draw a line through O. EF parallel to DC by construction. AB parallel to DC. Given AO upon BO, CO upon DO. Required to prove AB parallel to DC. Required to prove AB parallel to DC. One pair of opposite sides are parallel. Then the quadrilateral is trapezium. Required to prove AB parallel to DC. Here draw a line through O. EF parallel to DC by construction. EF parallel to DC, then OF parallel to DC. Then OB upon DO is equal to BF upon CF. This is considered equation 2. From equation 1, cross multiply. AO upon CO is equal to BO upon DO. Equation 3. Compare equation 3 and equation 2. Compare 2 and equation 3. In both equation BO upon DO, BO upon DO. One side is BO upon DO. So compare 2 and 3. AO upon CO is equal to BF upon CF. Taking reciprocal on both sides. CO upon AO, CF upon BF. Now AO, CO upon AO is equal to CF upon BF. Consider triangle CAB, OF parallel to AB. OF is the line segment of EF. OF parallel to AB conveys basic proportionality theorem. Then EF parallel to AB. EF parallel to DC. Then AB parallel to DC. Quadrilateral of ABCD is trapezium. Here over the relationship between trapezium and similar triangle. The problems are over. Thank you for